Welcome. Now you would have noticed that I haven't posted a CNC video for quite a while. Now this power supply of the spindle motor has given me issues. Now with zero load it's giving me 12 volts, and as soon as you start up the spindle motor, then it drops down to 6. Now I've checked through all the components. Most of or basically all these transistors are bipolar junction transistors, and they were easy to test and they all check out fine. And it came down to this potentiometer here on the end here. Now I've measured a value of 87 kilo ohms, not 87, 84, which in the first place is not a standard value. And secondly, the value of this pot is supposed to be 1 kilo ohm. So which tells me that this pot is either burnt, or my other theory is it might be that it came loose or worn out because of vibration. Now the reason why I think I'm leaning more towards the vibration theory is the fact that I've cut aluminium with it, and that machine rattles like crazy when you do that. The MDF board starts to resonate, and I think that carries through to the whole machine. So what I'm going to do is I'm going to replace this little pot. Got myself some space here, and then see if the power supply picks up after that. As you can see, this one is giving the right value. It's around 1 kilo ohm. And if you look at this spot, it's running into the hundreds of kilo ohms and it's still climbing. It's acting like a capacitor instead of a potentiometer. Sorry about the focus. Let me just show you again. As you can see there, on the multimeters, ohms is climbing. It's like a capacitor. And on this one, it's steady in 1 kilo ohm. Right, so I think this should solve my problem. Now this power supply, the cheapest that I've seen on websites was around 600 bucks, and a new potentiometer cost me 350. So it's definitely worth it to fix it. Another thing to note as well is that the thermal paste at the back of your power transistors, semiconductors, tends to dry out. Now once they dry out, they lose their ability to transmit heat properly, or they call it thermal conduction. And so your components won't last as long as it would have if this was maintained properly. So what I'm going to do is I'm just going to add some new thermal paste to it and then reassemble it. Okay, we've got power, LEDs on. We've got 47 volts. I think we're back in business. So all I need to do is just to adjust the voltage or the pot until it gives me 48 volts on the dot. And there it goes again. Okay, 48 volts on the dot. So we're back on track. So I hope this was informative. Now the whole idea behind this video is just to show you that you don't have to replace the power supply every time there's some hiccup on it. These things are reasonably easy to fix. There's not a lot of components that can go faulty. When the power supply is very old, it will be likely that the capacitors will be blown. And easy to see that. You'll see the caps of it will have a concave shape to it. It would have swollen up. Then you know it's definitely blown. If you replace it, the power supply will be working again. And you'll see there's a thermocouple there. Now, sometimes these thermocouples tend to burn the contacts, especially if they cycle a lot. But in this case, this power supply shouldn't cycle a lot because it's only there to protect the circuit against overheating. Another thing that will usually go is your power transistors. Now they're also an easy fix. So there's not really much to these power supplies. So next time if you have a problem with one of these, don't buy a new one, just fix it. Cost me 0.5% of what the new power supply would have cost me. Yeah, more or less. Okay, until next time, cheers.